if you think about the team, we're not the biggest producer of cars in the world. We make 5 or 6 chassis a year. Those of you that don't understand a chassis, if you think about from the beginning of the nose where the driver's feet are to just behind him, we only make 5 of those. The rest of the car depends on how well we're doing, on how many iterations we'll make. So as a production company, we don't make a huge number, but we make them very, very fast and iterate very, very quickly. We move around the world every week or every other week, and we take what most people in the room, who's IT side rather than data side in the room? So IT people rather than maybe data? So majority data people, would I be right? Okay, about 50-50 actually. Okay, so we take around the world the equivalent of what most people would have in a branch office. So multiple servers, our data storage, SQL servers, domain controllers, everything that you would want. We have around about 40 gigabit switches. We have around about 200 clients. So everything that you would probably have in your normal branch office. The difference is that we take about 36 hours to take that out of some boxes, to turn around and put that into the environment that you would see at the track, and then basically for people to use it for 4 to 5 working days. And then we take around about 6 to 8 hours to pack it all back up into boxes, take it to the next country and expect it to be pristine and working. That might sound simple to some of you, but most of you are used to having your IT infrastructure in a nice air-conditioned office. We put it into our garage with no air conditioning. We have to work on the worst environmental conditions that we have at any track. So to try and put that into context for some people, we'll go to Malaysia, so 70–80% humidity. In the same garage, we'll have people that are grinding maybe carbon fiber, so you've now got carbon fiber dust in the air, in a very moist air, basically being sucked into IT equipment. Not quite the environment that some of you would prefer your kit was in. We turn around and Brazil that we just went to has some of the worst power supplies that we get given, to the point this weekend they blew up 2 of our UPSs before we'd even started the race week because an electrical engineer basically put the earth where they shouldn't have been doing. So we have to take the services and systems that are delivered to us by the particular tracks or countries. We then have to turn around and make sure that this is reliable. Now, my boss always wants me to say 100% reliable, but who in the room thinks they can do that in a nice air-conditioned room without the issues of moving around the world? I'm not sure many of us would say we could guarantee 100% all day, every day of the year. Of that, we cross 176 time zones. That's because of the number of times people travel backwards and forwards around the world. If you think about what that does to your body clock, let alone anything else, you still have to be performing at your best as people. There's a lot of time and effort gone into the last 2 years around actually culture within the team. So we talk a lot about our data and our systems and how we work as a team. But if we hadn't been working on our culture for the last couple of years, we probably wouldn't be up there above the other teams, and consistently being able to improve what we're doing and how we're doing things. The reason being, if you just look at technology, everybody's going to be able to keep up with changing technology or new ideas or new ways of doing things. But if we don't get the culture of the people right, then you're not going to advance, and those marginal gains, everybody's going to be doing those. So our marginal gains over the last 18 months, 2 years, has been really to worry about people and how we can improve things. One of the best ways to do that isn't to give them boring, mundane jobs, like looking at repetitive sets of data. You want to give them anomalies. You want to give them differences in what we've spotted in data. For them to turn around and actually find there's a challenge, there's an issue, there's something that they can use their brain cells to turn around and keep them excited, keep them engaged, want to work for the team. So we get to the track and we have 2 cars that go around the track. We produce around about 0.5 terabyte a race weekend. Not a massive number. If you consider that 0.5 terabyte, that's from 3 practice sessions, qualifying in the race. Every time a car goes out, due to limitations of some technology, we can only get 4 gig of data per car if a car does 1 lap or if it does a whole race. So the number of times we go out with the car, we turn around and we create, as I say, 4 gig of data approximately. When that data comes back in, though, we'll be looking at the data real time. That data is real time in the factory and at the track. But what we'll then do is we'll process that data to create more versions of the same data. So this will be adding maybe aerodynamic information that coming off the car is a standard single sensor. That sensor on its own right gives us some information. But if you compare that sensor with 2 or 3 other bits of information that maybe don't come from the car, maybe it's weather conditions, maybe it's track temperature, other information that come from other systems, we can then start to infer other information about our car. We can